Hello everyone, welcome back to Civil Learning Online, and today in this video I am going to discuss about how to solve a problem based upon the eigenvalue and eigenvector. Here also I am going to solve a matrix in which we are asked to find the eigenvalue and eigenvector. So without any further delay, let's get started and let's learn what is the statement of the eigenvalue and eigenvector with definition and with a problem. So guys, let's begin the solution of this problem, and here we are asked to find the eigenvalues and eigenvector of the given matrix A, and matrix is 1 0 minus 1 1 2 1 2 2 3. So guys, before beginning the solution of this problem, first of all let us understand the meaning of the eigenvalue and eigenvector, or we can say the statement for the eigenvalue and eigenvector. So here we go. We have statement as let A be a square matrix of order n, and if there exists a number lambda and a non-zero vector x such that ax equals to lambda x, then lambda is called eigenvalue and x is called the corresponding vector, means eigenvector. Okay, so here we say if A is any matrix of any order, either 2 by 2 or 3 by 3 order, and if there exists a condition such that Ax equals to lambda x, then in that case we will call lambda as eigenvalue and x is called the eigenvector. So here when we begin the solution of this video, first of all what we need to do is we have to consider equation in the form of A minus lambda I times x equals to 0, and from there we will proceed and we will learn how to do the solution of any problem based upon the eigenvalue and eigenvector. So here we go. I'm going to write here solution, and here we will proceed with a minus lambda I times x equals to 0. Okay, this is the equation from where we begin our solution. So let it be represented by equation 1. After that what we will do, we will simply put the value of matrix A, and so let me write the value of A. Matrix A is 1 0 minus 1 1 2 1 2 2 3, close the bracket, and lambda I is identity matrix, so identity matrix of 3 by 3 order is 1 0 0 0 1 0 0 0 1, close the bracket and multiply this by x, and let us represent x as x1 x2 x3, because these will be our eigenvector at the end of the video when we will start substituting the value of eigenvalue to calculate the value of x using the Cramer's rule. So this is what we do till up to now. Now what we need to do is we have to find the determinant of A minus lambda I. I hope you are getting. We will find the determinant of A minus lambda I. Okay, this is the characteristic equation, or we can say that A minus lambda I equals to 0 is the characteristic equation of the given matrix. Given matrix is A. In the in context of eigenvalue, eigenvector types of problems. So what we need to do is we have to find the determinant of a minus lambda I equals to 0. So here we will again put the value of the matrix. See here we have matrix A as 1 1 2 0 2 2 minus 1 1 3 minus lambda times 1 0 0 0 1 0 0 0 1 and determinant equals to 0. In place of equal to sign we will place implies. Here also implies, because we cannot put 2 equals to here. This is representing equation and here also it is representing equation, so we will put the sign of implies here, and further now we will need to solve this. So guys, after this step what we need to do is we have to subtract lambda from where it is possible. So here when we multiply, this lambda is going to multiply with each and every term which is inside the identity matrix, and then we will need to subtract. So see here we have 1 minus lambda, here it is term means we need to subtract only with the diagonal element, because all the other element when on multiplication with lambda is going to be 0. So when we subtract 0 from any number, it is as it is, so there will bring no any change. So here first term is going to be 1 minus lambda 0 minus 1. Similarly we will have here 1 2 minus lambda 2 2 3 minus lambda, and sign of determinant equals to 0. So after doing subtraction, what we need to do is we have to find the determinant. We can find determinant either with respect to this row or with respect to this column. So in this video I am going to find a determinant with respect to this row. So we will have here 1 minus lambda times cover all the elements in which 1 minus lambda lies. So we will cover this row, this column and this row. So we will have here 2 minus lambda 2 0 3 minus lambda. Similarly for 0, and we are finding the determinant, so we will use the sign of cofactor. So it will get minus 0 times something. When we multiply with 0 it will automatically get 0, and here it is minus 1, so minus 1 times cover the column and row in which it lies. So this and this will get covered, so we will have here 1 2 2 minus lambda and 2. So on solving this we will get a form. You do not need to do this hectic multiplication. So what we will do here, we will simply use a formula, because when we are resolving the characteristic equation, what was characteristic equation? Characteristic equation was a minus lambda I times determinant of a minus lambda I equals to 0. Okay, so on solving this we will get a form of polynomial which will be represented as lambda q minus lambda square p times lambda square plus q times lambda minus determinant of a equals to 0. I hope you got it. When we resolve, when we find the determinant of this characteristic equation, then we will get a polynomial of this form. Now what are p and q? So p is the sum of diagonal elements, and q is minor or sum of minors of diagonal element. How we will find the value of p and q and determinant of a, I am going to show you right now. See here, so I will write here lambda q minus p is sum of diagonal element. So here for that I am going to use the matrix which was given in the question, and here we have diagonal element 1 2 3. So sum of diagonal element is 6. 1 plus 2 plus 3 is 6. So I am going to write here 6 times lambda square plus minors of the diagonal element. So first diagonal element is 1, and minor of 1 is going to be 2 2 1 3. So I am going to write it on this both side. So 2 2 1 3. Put the sign of determinant because we need to find a minor of this element 1. Again another diagonal element is 2, so minor of 2 is going to be cover this and this means row and column in which 2 lies. So we will get 1, 2, minus 1 and 3. 1, 2, minus 1 and 3. Again, the minor of this 3 is cover this and this. So we will get 1, 1, 0, 2. We will get 1, 1, 0, 2. So what we need to do is multiply downward, take positive sign, upward negative sign, downward positive sign, upward negative sign, downward positive, upward negative. So on doing so, we will get here 4. Similarly, here we will get 5, and here we will get 2. So on adding this, we will get 5 plus 4, 9, plus 2, 11. So we will get 11 times lambda minus determinant of the given matrix. So how we can find determinant? See here. In order to find determinant, what we need to do is we will do 1 times we were finding determinant with respect to this row. So 1 times 2, 2, 1, 3. 2, 2, 1, 3. Again minus 0 times while finding determinant we will take the sign of cofactor also. So minus 0 times cover the row and column in 0 lies. So this column and this row is covered. So we will get 1, 2, 1, 3. 1, 2, 1, 3, and plus in play. Actually we add. So here, and as here it is minus 1, so we will write here minus 1 times the row and column in which minus 1 lies. So this column and this row gets covered. So we will get 1, 2, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2. So on solving this, we will get the value of determinant as 6. So here we have minus a determinant as per the formula. So 6 equals to 0. Now we will use calculator to solve this equation and find the value of lambda, which will be our eigenvalues. So I am going to show you how to solve equation using calculator. So for that we will go to mode, press 5 and look for the type of equation which we are provided with. We have ax cube plus bx square plus cx plus d form here. So we will simply press 4 and this equation is now selected. We will put the value. The coefficient of lambda q is 1, so press 1 and press equals to. Again we have coefficient of lambda square minus 6, so minus 6, press equals to. Again we have 11, so 11 equals to. Again we have minus 6, so minus 6 equals to, and press again equals to. We will start getting the value of lambda. That is, first one we have lambda equals to 1. Again press equals to, another value is 3. Again press equals to, another value is 2. Okay, so we have 3 values now of lambda. So what we will do here now, if these are our eigenvalues, so if lambda equals to 1, if lambda equals to 1, we have if lambda equals to 1, we have, now we will put the value of lambda in this equation here. So lambda equals to, we are putting lambda equals to 1, so we will get here 0, 1, 2, 0, 1, 2, 1, 1, 2. Okay, and from here we have and at the beginning see here, this much portion is this, and we have x1, x2, x3 because we are calculating the value finally the x1, x2, x3 are our eigenvectors, so we are calculating it, so we have to write it here x1, x2, x3 equals to 0. Now what we will do, we will do the multiplication here so that we will get some equations. So 0 times x1. What I am going to do here, I am going to take 2 equations. You have to take the equation in such a form that on subtracting the coefficient we will not get 0. None of the row or column on subtraction will get 0. So we need to take equation in that form. So here we have 0 times x1 plus 0 times x2 plus x3 equals to 0. Let it be equation 1, and again we will have x1 plus x2 plus x3 equals to 0. Let it be equation 2. Now what we will do, we will use the concept of Cramer's rule to find the value of x1, x2, x3. So here we have x1 upon, so cover the coefficient in which x1 lies, and we will have here 0 1 1 1. So here we have 0 1 1 1. Find the determinant. Again x2 upon x2, cover x2, we will have 0 1 1 1. Again 0 1 1 1. For x3 we will have x3 upon, cover this, we will have 0 0 1 1, 0 0 1 1. So on solving further, we will get x1 upon here we will get, here it is -1, and here we will have equation as minus x3, sorry for my mistake, and here it is -1. So on doing so, we will get 1 times 1 means 1, upward we will take minus sign, and downward we will take positive. So x1 upon 1 equals to x2 upon -1 equals to x3 upon 0. So from here we will get x1 equals to 1, x2 equals to -1, here it is -1 because we have covered this, so we have -1 here, so minus get +1, so we have x2 equals to 1 and x3 equals to 0. I hope you are getting these steps. Now let's move to step 2. So again the step will be repeated for lambda equals to 2. If previously we solved for if lambda equals to 1, so here we will do if lambda equals to 2. Again we will put the value of lambda equals to 2 in the given equation. So here we will put lambda equals to 2. In place of lambda we will put equals to 2. Like the step is similar like what we have done for lambda equals to 1. For lambda equals to 1 we put, in place of lambda we put 1, and we got this, and then we at the side we put x1 x2 x3 so that we could form the equation, and later we solve the equation using Cramer's rule to find the value of x1 x2 x3, like what we have done here. Similar step will be done for lambda equals to 2 also. So on doing so, we will get here -1 1 2 0 0 2 -1 1 1, and close this. So from here we could form equations like minus x1 plus 0 times x2 minus x3 equals to 0. Similarly, this time I will take this equation, because on adding these two we will get 0. For in that condition we will when you solving by Cramer's rule, we will get something by 0, means x by 0. In that case we could not be able to calculate the exact value, so this time we will take 2 times x1 plus 2 times x2 plus x3 equals to 0. Further we have x1 upon, now cover the portion in which x1 lies, so we will get 0 minus 1 2 1, 0 minus 1 2 1 equals to x2 upon minus 1 2 1 equals to x3 upon minus 1 2 0 2. Cover this. So from here we will get x1 upon 2 equals to x2 upon 1 positive negative, we will get 1. Similar is the step. So x3 upon minus 2. From here we will get x1 equals to 2, x2 equals to 1, x3 equals to minus 2. Similarly, we had one more value of eigenvalue, which was lambda equals to 3. So if lambda equals to 3, again if lambda equals to 3, we will get, on putting the value lambda equals to 3 in the portion like what we have done for lambda equals to 1, so we will get minus 2 0 minus 1 1 minus 1 1 2 2 0, and here we will put x1 x2 x3 equals to 0. Now form two equations so that we will get the value of x1, x2, x3. So we will get minus 2x1. We are multiplying these two matrices. So 0 times x2 minus x3 equals to 0. Again we will have x1 minus x2 plus x3 equals to 0. So here again we will do here, I am going to use this portion. See what we will have here, x1 upon cover x1 we will have 0 minus 1 minus 1 1 equals to x2 upon minus 2 minus 1, this is minus 2 minus 1 1 1 equals to x3 upon minus 2 0 1 minus 1. So from on solving this we will get x1 equals to, we will get x1 upon minus 1, x2 upon minus 1, x3 upon 2. So these are the value of x1, x2, x3 using the three eigen values. These are eigenvectors. So I hope this video was helpful to you guys. See you in the next video. Till then, stay safe and take care of yourself.